Okay, so good morning to everyone, and this is Robin, and I'll be handling your today's session for Cognizant Automata Fix Part 3. Okay, so let's start with yes. Okay, I've just taken some questions, so I don't want to clash whatever has been already taken yesterday. Okay, so let's start with this. Okay, so the first question is going to be a function filling question. Okay, whether the given parenthesis is balanced or not balanced. Okay, for example, I'll just start with this. Imagine they'll give you some set of parentheses like this. Okay, and open close. So, is this a balanced parenthesis? Yes, of course it is. As per the logic of the syntax here, see, you can see every open has a proper close. Okay, there is no extra open or there is no extra close, and as per the order, the open goes first and followed by the close parenthesis everywhere. It's correct. And whereas if I give you some other set of parentheses like this, and then if I give unnecessary open, okay. So whereas this was a balanced parenthesis, and this is not balanced. This is not a balanced parenthesis. Whereas something like this, okay, open, close, okay. And as you can see, this is properly balanced. As you can see, this open has a close, and 2 and 3 and 4. There are 4 pairs, and it is correct. Okay, this is also balanced. Okay, and now, okay, so what is the logic of finding whether a given parenthesis is balanced or not? Is it that we have to count how many opens are there for how many closes? In case if I go in that logic, okay, let's say this open has one close, okay, fine. This open has one close, okay, fine. And this open has another close, and this open has another close. So there are totally 4 opens and 4 closes. So does it mean that I have to count how many opens are there? And if it matches with how many closes, then it is balanced. If I follow that logic, let's say close open. Okay, this one. So as per our logic, this has okay, let's say open and 1 minute. So close open. Okay. So according to this logic, if I say the number of opens are equal to number of close, should it be balanced? No, of course not. See here, the number of opens are exactly equal to number of closes, but this cannot be balanced. So what is the logic? What logic are we going to follow? Okay, now just let me open an Excel sheet for further clarifications. Okay, 1 minute. Let me. Okay, and sorry. Yes. So let me change the size and 3. Okay, so let me use this for yes. So imagine I'm going to use an array. As you can see, it's a string. So let me say I have a string here, and these are the indices 0 and 1, 2, 3, 4, 5, 6, 7. So let me have an open, open, close, open, open, and then close, and then a close, and a null character. Okay. So how can I prove that this is balanced? Okay. So first, whenever I see an open, so normally you must have seen a method where they use stack, where when they see an element, open parenthesis, they push the element, and when they see a closed element, they pop it. So we are gonna use the same kind of logic. So whenever I'm gonna see an open parenthesis, I'm gonna increment. So I'm gonna have a variable called count, and initially this count starts from 0. Okay, and then come here. For the first time, when I see an open parenthesis, what I'll do is I'll increment the count and it becomes 1. And then when I see a close parenthesis, I will decrement the count. Now, when I come here, the count becomes 0 again because it is decremented. And again, I see an open parenthesis. I increment my count variable, which again becomes 1. And again, one more time, I'm seeing an open parenthesis, so I'll increment it again, and this becomes 2. And now I see a close parenthesis, so I'll decrement the count. So from 2, it becomes 1. And again, I see a close parenthesis, so from 1, it becomes 0. So at last, where it stops? At last, it stops in 0. So if it stops in 0, it means it is balanced. Okay, it works fine for this. So what about this logic? What if I have a string like this? Okay, let's say if I have a string like, okay, let's go back. Okay, and now instead of this, if I have, okay, open, close, open, close, close, open, let's say. So now I see an open, as usual, increment the count to 1, and I see a close. So when I come encounter a close parenthesis, decrement my variable, it becomes 0. Again, when I see an open parenthesis, increment my count, it becomes 1 again, and I see decrement, it becomes 0. Simple, right? Again, I see a close here. So from 0, if I decrement, it becomes -1, and now I see an open, it becomes 0. So because it became 0 here, can I say it is balanced? Of course not. So the only thing which is something fishy here is this -1. See, if I give you an opportunity that you can make it balanced, you can use any character, whether it's open parenthesis or close parenthesis after this fourth index. Can you balance this? You cannot. Of course, you cannot. You cannot do anything after this fourth index to balance this particular close parenthesis. So here itself, by saying this particular parenthesis itself, you can immediately break the whole statement and you can say it is unbalanced because you cannot do anything after this to make it balanced. You cannot literally. So the moment you see -1, you can instantly break and you can say it is not a balanced parenthesis. So this is the program what we're going to do today. First one is whether to find whether a given parenthesis is set of parentheses is balanced or not balanced. Okay, now let's go to the code. So as usual, let's start. Okay, let me save the program and 1 minute and just 1 minute. Okay, and yes, CTS part 3 is it? Okay, and open, and the first problem is balanced parenthesis. Okay, and as usual, start with your standard input output.h include it, and then let's start with main function with return type integer, or it's based on your choice what type of value you're returning from this function. Now the first thing, what else I need here? Okay, first I need a string, right? So let me have a string of size 1000. Just based on the constraint you can create it. Okay, then let me receive the string. Okay, scanf, and followed by the format specifier s, and then the address of the string. So the array name refers to the address. So automatically, without ampersand or with ampersand, when you mention str, it gives you the base address of str. That's it. Now after receiving the string, okay, what else I should do? What are all the variables I need? Just now I showed you I created a variable called count. Okay, so if you want, you can create count in character or integer. Why? Because see, both character and integer are literally the same. The only thing differs is the range of it. So let me have a variable called count, which is initially 0. Okay. So after receiving this thing, the next step, okay, as I showed you in this Excel sheet, let's start traversing from 0 and go up to when the string, the character reaches null. Okay. So let's start. Okay, start your for loop now, and let's have a variable called index. So let me declare a variable called index here. Okay, and index starts from 0, and just now I told you instead of having a string length, start the traversal from 0th index and go up to the null character until str of index. Index starts from 0 and index goes on. So until it encounters a character called null, keep on doing it. So now come here and until str of index not equal to, let's have null character. You can either mention this or you can just have str of index, because automatically when this reaches null character as per the condition block in this and I return 0, automatically it stops, and then followed by increment your index variable. Okay, the next thing what I have to do, okay, simple. When you see an open parenthesis you increment, and when you see a closed parenthesis you're going to decrement. So come here, have an if condition. If, okay, if str of index equals to the open parenthesis, immediately what I have to do is increment the count variable. Else, or else if you can have, okay, so else, because in this particular string we're going to only have open parenthesis and close parenthesis. In case if you have any other mixed symbols, you can go for else if and particularly mention only if it is close, you have to decrement it. So else, decrement the count. Now still here, okay, first let's do this. Okay, now let me print it. Okay, so if the count, as I told you, if the count is 0, it means according to us it is balanced, right? Okay, so printf, and let's say it is balanced. Okay, balanced parenthesis, and if not, I have to say it is not balanced. So based on the constraint you can have the statement here. So not balanced. Okay, so the problem with this is, just now I told you. So what is exactly the problem? Okay, let me run this first. Okay, 1 minute. Yes. And sorry for this here. Okay, now let me have open, close, open, close. Is it a balanced parenthesis? Yes, of course. And let me run it again. Okay, now this is not a balanced parenthesis, but according to our logic, it says balance. So what is exactly the problem? Okay, I told you, in case anywhere if count reaches -1, immediately stop. Anywhere if count reaches -1, immediately stop abruptly and just say it is not a balanced parenthesis. So go back here to the program part. Yes, and come down. Either you can have an if condition inside, or along with the condition block here you can give, and you should also stop. 1 minute. And sorry, okay, and if count not equals to -1, anywhere, in case if count reaches -1, immediately stop. And you can say whenever it immediately stops, of course when it stops abruptly from this loop, definitely count will be -1, and if count is -1, definitely it will not be satisfied with the true block and it will come to the false block. And now let me run this. Okay, so hold on, and now it's close, open, open, close, close, open, and now it says not balanced. That's it. Yes, we have completed this. Okay, so still now I've just taken one problem, which is balanced parenthesis, whether it is balanced or not balanced. Okay, so I'll just wait for 1 more minute, and let's say whether the streaming and everything, the audio quality, everything is right. Only if you comment in the comment section, I can see whether everything is going on right. If you have any doubt, you can ask me anything. Whatever doubts you have, you can post there in the comment section. I'll just wait for 2 more minutes. So just 2 minutes, and I'll be checking whether the streaming is going on properly and all things are correct. If there's anything wrong, you can just comment in the section. So 1 minute, I'm just waiting for your comments there. If there's any doubt you have, you can just ping me. Okay, and just 1 minute, and oh, sorry, I'm just listening my own audio. Okay, I see in the comment section. Okay, said, what are you guys doing in the comment section? Okay, okay, please don't use unparliamentary words in the comment section. Okay, of course, okay. So, can use this balance parenthesis using pointer method, sir. Okay, Atizil, of course. Okay, so now, okay, so I think everything is going fine, and I'll move on to the next problem. Okay, let's see what is the next problem is. And 1 minute. Okay, so I've just taken this question for you, and 1 minute. I'm just taking this. Okay, there's a small thing here, and they ask us. I think yes. I'll just show you the statement. Okay, so in Automata Fix, they'll ask you to print this, and I remember the statement. This is yes, they'll ask you to do this buggy program or something. This is a buggy program. I think this was a statement. Okay, so this should be your output statement. Exactly, this should be your output statement, and they will exactly tell us to print this. This is a buggy program with this double quotes. Okay, so what we have to do? Okay, so if I want to print this exactly, okay, let me just copy this. Okay, control C, and let me just directly try to print it. Okay, hash let me save it and just program one. Okay, and as usual, and standard input output dot h and your main function. Okay, and printf. Okay, and paste it. Okay, so they asked us to print this is a buggy program. As you can see the color suggestion here, you can see this is in blue color where the double quotes denotes the starting of a printing statement, and again this is being closed here, and again it starts here and it's being closed here. But what we have to print is we have to print this is a buggy program with this double quotes present. But if I run this, let's see what happens. Okay, it says there is an error. Of course, this buggy here, this is the part where we get the error. So what if I want to print this as well? Okay, so the purpose of having double quotes is to ensure that this is being inside within the statement, but this buggy is being excluded. But what I want to do is I want to print along with this. So this is where we have to bring in the escape sequence. So I have to make this double quote escape its purpose of being a close, you know, printing thing. So what I'm going to do is I'm going to use a slash here. Let's see. Okay, first I'm going to show you this, and let's see. Okay, now is this correct? Okay, so I'm just trying to make this double quotes escape its sequence. By using this, can I escape this purpose of double quotes? Let me run it again, and of course not. So now let me use this, and now you can see after using backslash, this color has turned into blue. And now if I run this, and as you can see, it prints this is a buggy program. So this is also one of the most important question in CTS. Now and then they ask in Automata Fix, and this is one more. Okay, and the next thing. Okay, so let's jump into, here's one more. Okay, I've taken some questions for you. Okay, now let's start. The next question here is, I think you can read this. Okay, let me zoom it for you. Okay. So write an algorithm to multiply the original increment matrix with its transpose. Complete the function method generate matrix int m, and yes, I think it is int size. Okay. So you have three parameters here. Okay. And then input, as you can see, the function method consists of three arguments. RC value, a positive integer representing the initial value s, which is a size, Rows, a positive integer representing the number of rows in the increment matrix. Columns, a positive integer representing the number of columns in the increment matrix. Output, return a two-dimensional matrix of integers obtained from multiplication of the increment matrix and its transfers. So simple. So they'll give a number, like let's say 1. If they give 1, we have to create an increment matrix, which means the following numbers will be in incremented order from 1. So if they give me 1, I have to create this matrix: 1, 2, 3, 4, 5, 6, 7, 8, 9, based on the number of rows and number of columns. The number of rows is 3 and number of columns is 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then as you can see, and the transpose matrix will be yes. Now if I take a transpose of this matrix where row becomes column and column becomes row, and this is what the result. And they're asking us to multiply this matrix and this matrix so that we'll get the answer as this. So as a function filling question, we have to multiply two matrices. Okay, so if there's any doubt in the question, what you have to do? So given a matrix in incremented order, we have to take a transpose of the matrix and we have to multiply the given matrix and the transposed matrix and have the resultant matrix. Okay, so now to have an effective explanation, let me change the dimensions of the matrix. Let's say I have a 3 cross 4 matrix. Okay, now the index are 0, 1, 2, 0, 1, 2, 3. And if the starting element is 1, of course it starts with 1, 2, 3, 4, and 5, 6, 7, 8, 9, 10, 11, 12. Okay, now 1 minute. Now as you can see this matrix. Okay, let me call this matrix as mat. Okay, and what dimension it is? It is in 3 cross 4 dimension. And if I transpose this matrix, as you can see, the row becomes column and the column becomes row, right? So let me take a transpose of this matrix. So this is how it will look. The dimensions have changed, sorry. Let me delete this. And yes. So as you can see, now it became a 4 cross 3 matrix. So 0, 1, 2, 3, and the index here 0, 1, 2. Okay, and how the elements will look like. Here you will have, it starts from 1 and then 5, 9, and then it becomes 2, 6, 10, and 3, 7, 11, and then 4, 8, 12. Okay, and let me call this matrix as transposed matrix, in short TMAT, with the dimensions of 4 cross 3. Now when you multiply two matrices, the resultant matrix will be in which dimension? So the resultant matrix will be in the dimension of row of the original matrix and column of the multiplied matrix, which is the row of the given matrix is 3 and the column of the multiplied matrix is 3. So your resultant matrix will be in 3 cross 3 dimension. So here if this is m cross n, this is n cross m. So my resultant matrix will be in m cross m, which is 3 cross 3 matrix. So 0, 1, 2, 0, 1, 2. Yes. Okay. And it's normal. Okay. This is how it look like. Okay. And let me call this as multiplied matrix MUL, which is in a dimensions of 3 cross 3. Okay, so now, so let me just check the comment section whether everything is going fine. Just 1 minute. Okay, I think everybody understood the question. Okay, okay, now moving on. So what we have to do? Okay, so you have this matrix, you have this matrix, and yes. So I can see a question is being raised here in the comment section during AMCAT Automata Fix, same problem using pointer method. Yes, very good. and I'll show, and I'll just, okay, better I'll use this problem and I'll just have a function separately to show what problem will occur. Now, so let's go. Okay, let's start. First, let us create two given matrices. Okay, so I'm not using any dynamic memory allocation here. I'm going to use a static array, and I'll tell you what problem will occur if you're using static array and a dynamic array. So let me save this, and multiplying matrix. Okay, now listen here. The first thing, as usual, your standard input output dot h and int main. Okay, so first we need two matrices. One is the mat yes, and we do not know the dimension. And then we have one more, that is t mat, and we do not know the dimension. And there is one more matrix, that is your resultant matrix, which is called as multiplied matrix, right? And okay, so the dimension will be determined only after you receive m, which is denotes the number of rows, and n, which denotes the number of columns. So integer m comma n. Okay, and then if I receive scanf, okay, let's receive both m and n from the user. So read it ampersand of m and ampersand of n. And after receiving this, the dimensions of matrix will be m cross n. The dimension of transposed matrix is n cross m, and the multiplied matrix, just now I told you, it will be in a form of m cross n. And what are the other variables I need? Okay, so due to the, okay, you can see this. Okay, so the other variables I need here are row and column. Okay, that's it. So these are the things we need. Okay, the first step, read the inputs and store it in the matrix. Okay, 1 minute. Okay, so let me go back. Okay, first starting with for, where your row starts from, it starts from 0, and then your row is less than the given number of rows. Okay, what it is, m, and then row plus plus, and then for column as usual starts from 0, column less than the number of columns, which is n, and column plus plus, and read the input scanf and format specify d comma ampersand of, store it in corresponding matrix of rows and columns. So in each row and column, store it properly. Now I've read the input, that is this. Okay, let's say 1 2 3 4 5 6 7 8 9 10 11 12. Okay, as they said, they want to store it in incremented order. It's very simple. You can have a value. Okay, come here, you can have a separate value which starts from 1, and then you can, instead of getting scanf, we can do this. That is, okay, so imagine, as per their logic, they have a value which starts from 1 and they want to create this matrix in an incremental order, right? So in the matrix of rows and columns, okay, we can insert directly value with a post increment. So automatically 1 will be inserted, 2 will be inserted, 3 will be inserted, it goes on until the number of spaces, the number of elements you have, the capacity of the matrix. Okay, now it's successful. Then moving on. Now I have to transpose the matrix, which is very, very simple. So transposing a matrix is just, you have to change the rows into columns and columns into row. Okay. So let's do this. Okay. So let's have a separate function to transpose a matrix. Okay. So now I'm going to create a separate function called transpose. Okay. Now please focus. Okay. And how many arguments this transpose function receives? Okay. First of all, you have to understand. Here, if I'm going to pass this t mat of n comma m to this transpose matrix, okay, the thing is, I have to call the function transpose by passing the base address of the memory of transpose, which is t mat. Okay, and then the dimension is n comma m. Okay, after I call this function, I should have the elements transposed and it should be stored in tmat. Okay, let's see. So what are all the arguments? Okay, what should be the formal parameter here? Okay, I'm receiving three things. The first thing is an address. It is not a one-dimensional address. Here it is a two-dimensional array. So the scaling vector will be pointer to pointer. And here you have n and here you have m. So the first thing is create a pointer to pointer variable, and I'm going to use the same name. No problem. Tmat. Now here tmat is a pointer to pointer variable which is going to store the address which is being referred by this function transpose, which gives the address of tmat, and then followed by I'm going to receive a value called n. Let me receive it with the same variable n, no problem. There'll be no clash because both are different scopes, and then integer m. Okay, now moving on, you have a pointer to pointer variable tman which receives the address, and integer n which receives the value which is being passed n, and this receives the value which is being passed by m. Now it's time to take a transpose. Okay, very simple. So what are all the variables you need to do, or what are all you need for transpose? Rows and columns. Okay, then start your outer loop, that is row starts from 0 and row less than what. As you can see, the dimensions for transposed matrix, it is n cross m and not m cross n. So the dimensions, the perspective of the table, what I have to see here is, according to me, the transposed matrix row is totally n times. So row less than number of columns for us is n, not m. Only for matrix it is m, and for us it is n. And then row plus plus. And for column starts from 0 and column less than the number of rows for the original matrix, which was m actually. So m, and for us it is number of columns for transposed matrix, and column plus plus. And now for matrix of row and column, should I store it in matrix of rows and column? No, of course not. In tmat of rows and columns, what are the values I have to send? Just now I told you transpose matrix is where matrix column and row interchange, and it is being passed to tmat. So tmat of row column equals to matrix of column and row. Now what error will occur in this particular matrix? First of all, do you know what is tmat? Of course, yes, the address is being passed here. I'm receiving it, no problem. Okay, so you know what is n? Of course, I know n because it's there in the formal parameter. I'm receiving it from the main function. But what is mat? Am I getting any reference for mat? Of course not yet. We did not pass mat. So I will get an error saying that mat is undeclared. So while calling the function transpose, also pass the matrix, the given matrix. So mat, which is also a two-dimensional array. So the reference will be pointer to pointer. So integer, let me have the same name, pointer to pointer matrix. Okay. Now, is there anything I have to return from this function? You need not return anything. It's because it is directly altering the values in the memory itself. So there is nothing for us to return from this function. So if there's nothing for us to return from this function, let's leave it as it is. Okay, first, let me see whether the array is being transposed correctly. For that, I'm going to print and check it out. For row starts from 0 and row less than n, I'm going to display the transposed matrix, and row plus plus and have a slash in printf slash in. And moving on, for column starts from 0 and column less than m and column plus plus. And now let me print it, printf and format specifier d and give a space comma transposed matrix of rows and column. Okay, let's see. Let's print and see what all the output are we getting on. Okay, 1 minute. Let me close it. Okay, and let's give the number of rows and number of columns as we have mentioned in line number 5. Okay, come here. Okay, so 3 cross 4 matrix. Okay, as you can see now, there is some error and the process returned with a negative value, which means it is not working. Either you are trying to access an unauthorized area. So what is exactly happening here? Now listen here carefully. So I've created two matrices, mat and tmat, and also okay, and here I've started it and row less than m, row plus plus, and in matrix of rows and columns I have inserted the value, and in transpose of matrix I passed mat, tmat, and n and m. Yes. And moving on, coming back here, I called a function called transpose, and first I passed matrix which I received here in a pointer to pointer variable, and then I called this integer tmat, and then I have created integer n and integer m. Everything is going fine. And then here row starts from 0, correct, row less than n, row plus plus, and column starts from 0, column less than m, column plus plus, it's correct. And in every tmat of rows and columns I'm inserting mat of column and row. So where the mistake is, and one more minute. And one more thing is, when you have a different return type other than integer, try to declare it, and let me declare it here. Okay. Now, so what are the other mistakes we have where the problem is? Okay, first of all, to check where the problem is, I'm gonna just have a printf statement here. First, let me check whether this function is being called properly. So I'm gonna check whether this function is being called properly. Just let me have a dot. So let's see whether this dot is getting printed. Okay, so and run it. Okay, and three. Sorry. Yes, 3 cross 4 matrix, and now I'm giving the dimension, and the dot is getting printed. It means that the function is being executed properly, but while trying to print I'm not getting it. So there is no problem here. Now after assigning this value, let's see all these statements are executing properly. For that, let me print a dot here. Okay, so this is how give a dot. So let me check whether this statement line number 24 is going to be executed. So let me run this, and again a 3 cross 4 matrix, 3 and 4. Okay, now as you can see the dot did not appear. It means the problem is somewhere here. And what problem is occurring? So just look into the problem. So you may have a same kind of code where you need to debug or something. So I'm just giving you 1 minute time exactly. So just check what problem is happening here. So after this particular statement, I'm not getting it executed. So the dot was not getting printed. So what mistake do you think is happening here? Just check it out. Okay, so I suppose you got the answer. First, what I'm going to do is I'm going to show to you without calling a function. Okay, I'm just going to copy this exactly and Control C, and I'm going to just hide this function. Let's see without calling the function. Let's see what happens. Okay, so this was the same question asked by someone in the comment section, and now I'm not going to call the transpose function, but I'm going to directly transpose it here and paste it. Okay, and now let me run this. Okay, 3 cross 4 matrix. Okay. So as you can see, I got a transpose here 1, 5, 9, 2, 6, 10, 3, 7, 11, 4, 8, 12. But what was the problem when I passed to a function? So now let me go back, Control Z, and yes. So transpose of mat of tmat, and everything is fine. Okay. And just take this out. Okay. So now as you can see, this is a static array, and this is a static array. Now, if I would have created this as a dynamic array, so let's say what happens then. Okay, now let me come here. Now, as you can see, everything here is in static mode. What if I create in a dynamic memory? Okay, using dynamic memory. Now, let me create the variable with pointer variables such as mat and such as tmat, and also the mat also I'm going to create it using a dynamic memory allocation. Now the next thing, okay, I'm going to allocate the memory for mat first. Okay, so starting with mat, and then equals to typecast integer pointer to pointer followed by malloc or cloc, and then followed by the number of rows. m into size of integer address, and followed by for each row of matrix I have to allocate each single dimensional array. So for row starts from 0 and row less than m and row plus plus, and then for every row, that is for every mat of row, I'm going to allocate integer return type integer address followed by malloc or cloc, and number of columns into size of the element which is going to present inside is integer. So I've dynamically allocated memory for matrix. Now how to dynamically allocate memory for transposed matrix? Copy the same thing and paste it here. Okay, and then that's it. And wherever you have mat, just change it as tmat. Okay, and the dimensions of tmat changes, so it is not m cross n, it is n cross m. So n, and it is n, and here it is m. Okay, done. And the next thing is allocate memory for multiplying matrix also, where it is m cross m, right? So paste it, and wherever you have mat, just change it to mul, mul. So here also it is multiplied matrix mul. And now the next thing, this is also m, this is also m, and the number of columns also is m. Okay, now I have changed this. All three are created using dynamically. Now all are dynamically allocated memory using malloc. So if you want to use the built-in function malloc, please include hash either standard library or malloc.h. Okay, and now I have created this dynamically. Okay, now let's see whether this problem occurs. Okay, run this. Okay, 1 minute, and yes, okay, we have an error, mat tmat. Okay, sorry, this is multiplied matrix, and run it. Okay, now let's see. So hold on. Okay, 3 cross 4. Okay, now you can see the matrix is being transposed. See, the problem with static array is that here, when you have it as a static array, the array which is being present, which is being created, or which was created here, when you go to the function and when you call another function transpose here, see, first of all, the memory will be deallocated the moment you come from the other function to transpose function. So it is always advised when you go from one function to other function, you're calling, or when you're working with different functions, try to use dynamic array where the scope of the memory will be throughout the program. So until you close the program, the memory will not be deallocated. So always try to stick on with dynamic memory allocation. Now, the first step we have transposed. And what's the next thing? Okay, after transposing, I have to multiply this matrix and the transposed matrix. Okay, so how to multiply two matrices? First, take the row of the matrix, okay, and multiply with the first column, that is zeroth column of tmat with this. So multiply this and have a summation of it and store it here. So very simple, no? So that is in multiplied matrix of 0, that is in multiplied matrix of 0 comma 0, which I have shown there with yellow color in this part. In here, what I have to store? Simple. In here, you have to store equals to, simple, that is this with this, that is matrix of 0 comma 0 multiplied by, that is this element should be multiplied with this element, plus this element should be multiplied with this element, plus this element should be multiplied with this element, plus this element should be multiplied with this element, that is mat of 0 comma 0 into t mat of 0 comma 0, plus enter, then mat of 0 comma 1, mat of 0 comma 1 multiplied by t mat of, that is this element should be multiplied with this element. So this is 0 comma 1, this is 1 comma 0. So mat of 0 comma 1 multiplied with t mat of 1 comma 0 plus mat of, again this 0 comma 2 should be multiplied with 2 comma 0. That is mat of 0 comma 2 should be multiplied with t mat of 2 comma 0 plus just one more, last one, this should be multiplied with this. That is, I think you must have drafted your own table here. That is the next one. Let me minimize it. Okay, that is mat of 0 comma 3, and I can see, you must have, now you must have just got your own logic here. I think everybody got the logic here. That is, you're multiplying this and this 2 into 2 plus 3 into 3 plus 4 into 4, and mat of 0 comma 3 into, so d mat of 3 comma 0. So I think everybody can foresee what I'm going to do next. Okay, so as you can see here, first I multiplied 1 into 1 plus 2 into 2 plus 3 into 3 plus 4 into 4. This is what I did. Okay, so that is fine. This is fine. What about this 0 comma 1 of multiplied matrix? What should I store here? Simple. The same row and multiply with the first column, this one. So what is the logic? This 0 comma 0 multiply matrix is the multiplication of this, and for this part, that is 1. Okay, let me change the color into red so that you can have a connection there. So this and this will be multiplied and will be added here. And what about this? The same row which is multiplied by the last column here. What about this? That is, first row here multiplied with 0th column is this, and again the first row multiplied with the first column is this, and again the same row multiplied with the last column gives you this. Okay, so now if I just write one more iteration here, I think everybody can figure out what is going to happen. Now let me write one more iteration. What happens in multiply of 0 comma 1? Okay, equals to, just one more iteration, you will figure out everything. Now in multiplying matrix of 0 comma 1, what should I store? Simple. Is this element should be multiplied with this element here. So let me write matrix of 0 comma 0 multiplied by t mat of that is this into this. So 0 comma 0 into 0 comma this 5, which is 0 comma 1. So 0 comma 1 plus mat of 0 comma 1 multiplied by t mat of. So now 2 is multiplied with 6, and where is 6 located? 6 is located in the coordinate of 1 comma 1, and everybody would have figured it by now. That is, the next statement is mat of 0 comma 2 multiplied by t mat of, that is 7. Where is 7 located? In 2 comma 1. So mat of 0 comma 2 multiplied by t mat of 2 and then 1 plus the last statement. See, you can see a sequence there. See here, 0 0 0 0 1 2 3 0 1 2 3 0 0 0, and here as you can see, of course this will be 0 0 0, the same row, and 0 1 2, the same column what we used in the previous one, and here as you can see the sequence 0 1 2 3, and this is 1 1 1 1. So matrix of 0 comma 3 multiplied with t mat of 3 comma 1. That's it. Now, by this, what you can understand. See, first of all, we are going to traverse this, right? So every row and every column we are going to traverse. So first, as you can see, first I found what is 0 comma 0. Then I found what is 0 comma 1. Then I'll find what is 0 comma 2. Then I'll find what is 1 comma 0. So to traverse this, normally what we will do, we'll take a variable called row r, and where we will start it from, we'll start it from 0, and up to where we'll go, up to, we will go up to it is less than m, because there are totally m number of rows. Yes, in what fashion? In an incremented fashion. So row starts from 0, row goes up to less than m in an incremented fashion. Then we have one more variable called column, where column starts from the same 0 and column goes up to less than m. Number of columns is also m times, and this also goes in an incremented fashion. Fine. So yes, everything is fine. And as you can see, this this is row, this will be controlled by row, and this will be controlled by column. When both of them are 0, who are all in this iteration matches or on par with the rows and columns. As you can see, everything is 0 here, right? In the next iteration also, everything is 0. So this here will be controlled by row. The whole iteration here will be controlled by row. And what about this? Okay, column will be 0, and then column will, it is 0. See, actually here what was here actually in multiple of row comma column was 0 comma 0. So what is on par with 0 comma 0 for the whole iteration? That is this particular sequence here. This particular sequence here, 0 0 0 0, which is being controlled by row, and here also, as you can see, 0 0 0 0. And what is the difference between this and this? What is the difference between this and this? So here the row is 0, column is 0, but here the row is 0, the column is 1. And what difference is there inside? Here everything is 0, and here everything is 0. Here everything is 0 here, but here everything is 1, because the column changed to 1 and everything here changed to 1. But whereas the column of this, see here, 0 1 2 3, here 0 1 2 3, here 0 1 2 3, which is not in par with row, also which is not on par with column as well. So the only areas which are being controlled by rows and columns are this. So mat of row and then mat of column. Only these are being controlled by with rows and columns. Then what is the other variable? The other variable is very simple. I can take an extra variable. Let's call it as k. And where k starts from? K starts from 0. And up to where k goes to. See here, 0, 1, 2, 3. There are totally 4 elements. But what is the value of m? M value is 3. So of course k is not less than m. K is not less than m, but k is less than n. And what is the value of n? N is 4. That is why this is 0, 1, 2, 3. See here? And this also goes in an incremented fashion. Simple. So row is less than m, column is less than m as usual, but k starts from 0 and goes up to less than n. Totally we need 3 looping statements. Simple. So I'm going to apply the same logic here. Back. Okay. That's it. We have a separate function for transpose, and we're going to have a separate function for multiplying two matrices. So let's have it as multiply matrix. Okay, mul matrix. And what are all the elements I'm going to receive here? That is integer. Okay. So based on the actual parameter, I'm going to set it. So what are all we need? What are all the functions we'll call here? Okay. So let's not have this because we know how to transpose it. Okay. After calling transpose of matrix, we'll be calling the function called mul matrix. Okay, what and all should I pass to multiply? The first is you have to pass matrix. The next is you have to pass the transpose matrix. And next is we have to pass our resultant matrix, the memory call MUL, and the dimension, number of rows, comma, number of columns. Call this function. After calling this function, let me display the multiple matrix and you will get the answer. So now let's come here. The first argument which is being passed is mat, right? So pointer to pointer mat. The next is integer, pointer to pointer t mat. Then next I'm receiving integer, pointer to pointer multiplied matrix, integer, number of rows m, comma, integer n. Now everything is ready. We are receiving the arguments as usual in whatever order we have given in the actual parameter. That is what there in the formal parameter. Next, come here. First step, we have to multiply, right? Okay, as you can see the logic, these are the looping statements. So what are all the variables I need? Row, column and k, right? So let me go to the programming section and row, column, and k. So integer, I need a variable row, I need a variable column, and an extra variable called k. Come down. The next is traverse the rows and columns of the multiplied matrix, that is row less than m, column less than m. Okay, come here, go to the section. For row starts from 0, row less than m, no problem, and row plus plus. And column also starts from 0, and column also is less than m, and column plus plus. But whereas k, where k starts from 0 and k is less than n, and it goes in an incremented fashion. So for k starts from 0 and k less than n, and then k plus plus, that's it. And just one more statement here. In every multiple matrix of rows and columns, what should I do? As you can see this statement, what is happening? That is row comma 0 1 2 3. Who's controlling 0 1 2 3? This k. So it's very simple. The statement is very simple. Mat of row of k multiplied by t matrix of k comma column plus. Now what is the value of r k here? Now the value of r is 0, the value of k is 0, the value of k is 0, the value of c is 0, plus then matrix will be 0 and k will become 1, and again column is staying 0. See, as you can see, only k changes here. So the same statement I'm going to write, that is in multiplied matrix of rows and column. What is row and column initially? 0 plus or equal to, because I'm going to add all the four statements here based on number of columns. So come here, matrix of what? Row comma k. So matrix of row k multiplied by, what is multiplied by? It is multiplied by t mat of k comma column, that is t mat of k and then column. That's it. That's it. And now, okay, is there anything for us to return? There is nothing. So let us go back to the function, main function, and let's do one thing, and let us display this. Okay, very simple. For row starts from 0, row less than m cross m matrix, so row less than m, and then row plus plus, and then for column starts from 0 and column less than n and column plus plus. Is it? No, it is not n, it is m cross m matrix. And for every statement, just have, for every row, give a new line and come out and printf and format specified d, give a space, and then comma print multiplied matrix of rows and columns. Now let's see, there'll be one problem here, and I'll show you what problem it is. Okay, and now let me run this F9, and yes, one, I'll just close the exe file here, and now let me run it. Okay, now I'm going to exactly give the dimension what they gave, that is 3 cross 3 dimensions, right? And yes, now as you can see, I'm getting some random garbage values. And what is the reason of having this random garbage value? It is because here in multiplied matrix, you have given multiplied of rows and columns less or equal to, that is the previous value plus mat of row of k into t mat of k of column. So initially the multiplied matrix should be a cleared state memory. So if you want to have multiplied matrix to be a cleared state memory, instead of using mlock here, you could have used clock, which would have made the memory clear. So clock, as we are passing clock needs two arguments, so comma, and here also you have to change it as clock. So clock and m into size of integer, we can give comma. That's it. And now let me run it, and 3 cross 3, hold on. Now let me give 3 3 and just run it, and now you got the answer: 14 32 50 32 77 122 50 122 194. So let's check with the given question, and let me go to the question. Is the answer correct? Yes. 14 32 50 32 77 122 50 122 195. So folks, here you must understand one thing. See, everything you cannot just understand by seeing it visually. So the most important thing here is you have to have an hands-on experience for yourself. So you need to have it for yourself. So run this program, have the same code, just don't get into the code. As I can see the Excel sheet here. See from where to where I have to multiply. Write the iteration, write down the iteration either in your memory or in somewhere. So either use an Excel sheet or a notebook, write it down, and then one by one for yourself frame the algorithm. After framing the algorithm, try your code. So instead of directly copying the code and pasting it, so do something like this. Have an algorithm, first be prepared, first understand how to multiply two matrices, what will be the resultant matrix, how it will be, just write down everything. See, whatever I've done, what have I done here? I've just showed you. It's basic mathematics, you know, what we must have studied in our childhood days. So the same thing. So just we have converted it into a code. That's it. So please have an hands-on experience for yourself, and then make mistakes. Understand for what mistake it is, because Cognizant is all about correcting mistakes. So Automata Fix will be given. You have to mix. You have to fix the errors there. Okay. So yes. So that's it. So what we'll do is just let me break this particular video and let me just create a second segment so that a video clip will be short for at least for 1 hour. I don't want to make a video for continuous 2 hours. Just just give me 2 minutes of time. I'll just create one more video here, and thank you so much. So this is Robin again here, and I'll be creating one more video, and thank you.